G'day team, welcome back to another video. Today we're going to be continuing our work with trig relationships, and we're also going to introduce the double angle identities. First, we're going to start looking at how to sort of implement our factorizing skills from quadratics into simplifying trig expressions. And then we're going to utilize double angle identities to help simplify and solve for some unknowns. So let's jump straight into some examples. Let's factorize and simplify the following expressions, okay? It's a bit tricky to sort of start looking at what needs to go where, but we've got to think, we've got to treat our trig functions almost like an x. If I gave you these equations with an x, they would be a lot more easily identifiable as quadratics that we could then simplify. So let's start having a look at this first term here. So part A. So on the top line there, I've got 4, take away 4 sine squared theta. Now there's a common factor of 4 in that top line. So let's take that out the front. All over 1 take sine theta. Now, we still can't quite cancel things out because it's a sine squared theta and a sine theta. But I see here, 1 is a square number minus another item squared. So that is actually a difference of 2 squares. Now, thinking back to quadratics, I know the difference of 2 squares can be simplified into a plus b and a minus b. Sorry, I'm getting a bit confused. Okay, so if I re-expand that out, I'm actually just going to get back to this result here. All over 1 take sine theta. Now, because everything on the top is a factor, I can now cancel out these 2 terms, and I am just left with 4, 1 plus sine theta. And we're going to leave it like that. That is simplified. All right, let's have a look at part B. Now, if I replace these cosecants with x, it looks like this. Now that is a quadratic that we know we can factorize quite simply. So let's go through our factorizing rules. There's no common factor. It's not a perfect square. It's not a difference of 2 squares. Let's try and use sums and products. So I know 4 and 2 multiply to 8, but 4 and 2 also add to 6. So they're my 2 numbers. So this is actually equal to cosecant theta plus 2 times by cosecant theta plus 4. And that's it. That's done. All right. Super simple. You've just got to try and imagine these as quadratics to make our life a little bit easier. So let's have a look at the double angle identity. So we've seen every now and again when we have 2 theta in here. We saw it when we were solving trig equations with algebra, and we sort of doubled the domain and went from there. But we can actually use these identities to simplify expressions. So sine of 2 theta is actually equal to 2 times by sine theta times by cos theta. That is the only one for sine of 2 theta. The tricky one is cosine of 2 theta. It actually has 3 different options. So you can have cosine squared theta take sine squared theta, 1 take 2 sine squared theta, or 2 cos squared theta take 1. Now, it is up to you to choose the correct one. Can be a bit tricky identifying that to start with, but you'll get better as time goes on. I've also got a tan of 2 theta identity. So tan of 2 theta equals 2 tan theta over 1 take tan squared theta. So we can use these identities to simplify and solve equations. So let's have a look at some examples. So given sine theta equals 2 on 7, and cosine theta equals negative 3 on 7. Find sine of 2 theta and cosine of 2 theta. So sine of 2 theta, we saw above, was 2 sine theta cos theta. Now, a lot of people get stuck in the sort of habit of substituting 2 on 7 in for theta and doubling it. But we can't do that, okay? Because sine theta equals 2 on 7, not theta. So we need to use our identity. Substituting in our values, so sine theta is 2 on 7, and cosine theta is -3 on 7. So we get 4 -12 on 49. And I don't think that's going to simplify any further, so we're just going to leave it there. Let's have a look at cosine of 2 theta. Now, because I'm given both sine theta and cos theta, it doesn't actually matter which one we use. So we are going to use the first one. So cosine of 2 theta equals, and it is cos squared theta take sine squared theta. All right, let's substitute in our values. So I've got -3 on 7 squared take 2 on 7 squared. So I've got 9 on 49 take 4 on 49, which is 5 on 49. Okay, so we're actually going to start applying some values here as well. All right, let's have a look at another example. So if sine theta equals -5 on 7, okay, -5 on 7, and we've got theta in between pi and 3 pi and 2, we want to find sine of 2 theta and tan of 2 theta. So let's just start having a look at sine of 2 theta. So that's equal to 2 sine theta cos theta. Now, we don't actually have enough information as is to start solving this. We have the sine theta, but we don't have a cosine theta. But we know some other identities that we can use to find cos theta. So we've done this before. Sine squared theta plus cos squared theta equals 1. All right, so this is our Pythagorean identity, our main sort of boss level A tier, S tier trig identity that we're going to use. So we know sine theta, so we're going to substitute that in. -5 on 7 squared plus cos squared theta equals 1. -5 on 7 squared we know is 25 on 49 plus cos squared theta equals 1. Subtract 25 on 49 from both sides. Cos squared theta equals, that's going to be 24 on 49. And then I take the square root, cos theta equals. So now we've got to work out if it's positive or negative. Now it is in quadrant 3, so that means my cosine is going to be negative. So it's going to be negative the square root of 24 on 7. Okay, let's now apply that into our trig identity over here. So 2 times by sine theta times by cosine theta, just like that. So I've got 10 root 24 on 49, and that is my sine of 2 theta in exact form. Let's have a look now at tan of 2 theta. Now tan of 2 theta, if we go back up to our identities, is 2 tan theta over 1 minus tan squared theta. So 2 tan theta over 1 minus tan squared of theta. Now, I don't know about you, but I can't find tan theta anywhere. So we're going to have to find it. Now I'll go back down here. Tan theta is equal to sine theta over cos theta. Okay, so let's throw that in now. So -5 on 7 all over negative root 24 on 7. We're going to get a positive number. 7s are going to cancel out. I'm left with 5 on the square root of 24. So let's put that information into here now. So I've got 2 times by 5 on root 24 all over 1 minus 5 on root 24 squared. So I've got 10 on the square root of 24 all over 1 take 25 on 24, which we can replace with -1 on 24. All right, so this is negative 10 on 24 root 24. Hopefully, this has helped a bit. Using our double angle identities, we're now building up a pretty big repertoire of trig identities that we can use to help us simplify some of these expressions. So, I'll see you in the next video. Thanks for watching.